Hey everyone, in this video we are going to solve the word ladder question on Leetcode. So we are given a begin word and an end word and a list of words working as a dictionary, and we need to return the number of words in the shortest transformation sequence to convert this begin word to the end word. And the condition is that every adjacent pair in that sequence should have a difference of a single character only. So for example, in the first example, we have begin word as hit, end word as cog, and we have this particular word list. And what we start with hit, then we go to hot, because hit and hot only have a single character difference. We only needed to replace this I with O. Then from hot we go to dot, because again a single character difference. We replace H with D, and if we keep doing so, we reach the end cog and we need to return the length of the words present in that transformation sequence. So this is the question. Let's say how we can do it. So we have our begin word, our end word, and a list of words. And we are given a rule that the difference between the adjacent pairs must be of a single character only. So our first difficulty that, or the first challenge that we see, is how can we determine that the difference between two words is of a single character only. So let's say if we pick the first word from the list, hot, what are the possible scenarios or what are the possible patterns it can be converted to? So we have three possibilities. First one, we replace the first character with something. I represent the replaced character with star and keep the other two as it is. Another possibility is for a one character difference that we only need to replace the second character only and keep the other two as it is. Similarly, for the last one, we keep the first two as it is and replace the last character with something. If we pick another word which is dot and try to do the same thing for this as well, it also has three possibilities. So first one is replace the first character, so HOT, replace the second character, or replace the third character. Now if you see that we have two similarities here, so this one and this one, they both are same. So using this method, we can create kind of an adjacency list. And in that adjacency list, it will be a value of key value pairs, so in which key will be a pattern and value will be the array of words that this pattern may match to. So for example, in case of this pattern star OT, up to now we have found two characters which can match this pattern. One is hot, another one is dot. So we know that these two words have a single character difference between them. So doing so, we can create a adjacency list of all the words which have only one character difference between them. And our final adjacency list will look something like this. So let me increase the width. Yep, as we see that this particular pattern, star OT, have these three following words in it: hot, dot, and lot. So we can know that all of these three characters have a single character difference between them. We replace the first one for them. We replace the H, T, or L, and we can get the other adjacent word. And now once we have created this adjacency list, it becomes now a graph problem. So what we can do, we can just simply run a BFS to find the shortest path to go from our begin word to our end word from this adjacency list. Let's try this in a dry run. So to run BFS on our adjacency list, we'll need three things. First, a queue. Next, a visited array or a visited set, whichever works for you. I'll be using a set, so it will be, let's call it visited. Next, we'll have our output variable. Let's call it result. Initially, its value will be 1. Since we are beginning from our begin word, since we are starting from our begin word, so we'll add this begin word to the queue and to the visited set as well. So we'll add hit. Cool. Now we'll start the BFS. So first we'll remove the element from our queue. We'll use dot shift method in JavaScript for this. It will remove the element from a queue and return us the element. So our word will become hit. It is our first word. So now we'll do the same thing what we did while creating this adjacency list. We'll replace the characters one by one with an asterisk or a star and check all the adjacent elements present in the adjacency list and add all that words to back to our queue. And once we reached the final end word, we'll return the count, which will return the count present in our result variable. Let's see how. So for this hit word, first what is the option? We replace the first alphabet with an asterisk and keep the other two as it is. Okay. So is there any pattern or any key matching to this particular pattern? Star IT. Yes, there is. This one. This one is matching and it contains a word hit in it, but it is already present in a visited array, so will not do anything. Next, what is the other pattern? We replace the second word H asterisk T. So is there a key present with this pattern? Yes, there is. It contains two words, hot and hit. Hit is already present in the visited array and hot is not. So we'll add hot to our queue. Next, what is the third pattern? We can replace the third character, so it will become HI asterisk. So we see, is there any matching pattern for this HI asterisk? Yes, there is. It contains the word hit in it. We have already visited it, so we'll not do anything. So this first word is completed, and the value of result is 1 because we have just used the first word up to now. Next, we'll pick the another word from our queue because our queue is not empty yet. The word will become hot, and we'll update the value of our result or the count of our sequence to 2 because now we are using the second word from our word list. So for hot, we'll do the same thing. What are the possibilities? What are the possible patterns? First one is to replace the first character. It will become star O and T. We'll check star O T is present in our adjacency list. Yes, it is. What are the words present in it? It's hot, dot, and lot. Hot we have already covered, and also once we pop this element from our queue, we'll add it to the adjacency list as well. Okay, so for hot, for star OT, we have three words hot, dot, and lot. Hot is already present in our visited set, so we'll not do anything. Dot and lot are not visited yet, so we'll add them to our queue. So we'll add dot and lot to our queue. Cool. What is the next pattern? We can replace the second character. It will become star H asterisk T. So we have already covered it. As asterisk hot and hit both are visited, so we'll not do anything. What is the next one? We keep H, O, and asterisk. Is there any key matching to this pattern? Yes, there is. It's hot. We have already visited this word, so we'll not do anything. Okay, we have covered the second word. Next, we pick the third word from our queue, which is dot. So our word will become dot, and we'll update the value of our result to 3 because now we are at the third word that we are using. So similarly, we add this one to the visited array, to the visited set. Now for dot, what are the possible patterns we can get? We have star OT, we have already visited it, so we'll not do anything. Next is D star T. So is there any words present in it? Yes, yes, a key is present with this particular pattern star D star T. It contains a word dot in it, but it is already present in the visited array, so we won't do anything. Next is D O star. So is there a key present in it with D star with D O asterisk? Yes, there is. It contains dot and dog. Dot we have already covered. Dog we have not. So we add dog to our queue. Cool. So we covered the third word now as well. Now the word we'll pick the next word because our queue is not empty yet. We pick lot. LOT. We pop this from our queue, add it to the visited array or the visited set. I'll keep saying it array. And we see what are the possible patterns for lot. We have three options. Asterisk OT already covered. Then L asterisk t. So L asterisk T, is there anyone present in it? Yes, it is. It contains single word lot in it. We have already visited, so we won't do anything. Next, L O star. Is there a word present in it? Is there a pattern? Is there a key present with this particular pattern? L O star or L O asterisk? Yes, there is. It contains two words in it, lot and log. Lot we have already visited. Log we have not. So we add log to our queue. So our third word is also completed now. Now we pick the next word from our queue, which is dog. We pop it from our queue, add it to the visited set, update the value of result. It will become 4. What are the possible patterns for this one? Star O G. So what are the so is there a key present with that? So is there a key present in the adjacency list with this particular pattern? Asterisk OG. So asterisk OG. Yes, we have dog, log, and cog. Dog we have visited. Log present in the queue. Cog we have not visited, so we add cog as well to our queue. Cool. What is the other pattern? We have D asterisk G. So is there a word? Is there a key? Is there a key matching this pattern? D asterisk G. Yes, there is. It's dog. It is already present in the visited array, so we won't do anything. Next one, D O asterisk. We have already covered it. D O asterisk dot and dog. Both are covered. Both are already visited, so we won't do anything. This one is also covered. Next, we pick the other word from our queue, which is log. We check what are the possible. Oh, so first we add it to the visited set. So we add log it to it, and we add result, and we update the value of result from 4 to 5. Okay. Now we check what are the possible patterns. So we have asterisk OG, asterisk OG already covered, dog, log, cog already covered. Then we have L asterisk G, L asterisk G. We have already one word in it. Log already covered, present in our visited array, so we won't don't do anything. Then L O asterisk. Let's see, there is a key matching this pattern. L O asterisk. Yes, there is. It contains log and lot and log. We already covered it, present in a visited array, so we won't do anything. Okay. Next, we have the final word cog in it. Does it match to our and does it match with our end word? Yes, it does. So we result this final value, which is 5, as an output. The time complexity for this one will be O of n dot m square, where n is the length of the number of words we have total, and m is the uh, length of a single word, which is 3 in this case. So this is the drawing explanation. Let's see how we can do it in code. So let's just first handle the edge case. So what if the end word is not present in the word list? In that case, it is not possible to create that sequence if no such a sequence exists. In that case, we just return 0. So for that, we'll write if not of word list dot includes end word, we'll just return 0 as an answer. If otherwise, we need to create an adjacency list first. So we'll create, I'll name the variable as adj list. It will be a map. Next, let's declare a variable for our length. So we'll call it m. We'll call it end word dot length. Since all the words, begin word, end word, or the words in the word list will be of equal length, so it doesn't matter. Next, we'll check again if begin word is not present in a word list, then we add it to the word list. So if not of word list dot includes begin word, then we just simply add it. So word list dot push begin word. Cool. Now we create the adjacency list. So we'll use a for loop for it. So for let word of word list, we pick all the words from the word list one by one. Next we create another for loop. So let I equals 0, I is less than m, since all the words will have equal length, I plus plus. Next we create a pattern. So const pattern, it will be replacing one by one each character with an asterisk, and keeping the rest of the word as it is. So word dot substring will be from 0 to I. Then we add an asterisk to it. Then word dot substring the rest of the word, so I plus 1. So now we check if this pattern is not present in the adjacency list. So let's call it pattern. So if not of adj list dot has pattern. So if it doesn't if the pattern doesn't exist as of now, we just push an empty array to it. So adj list dot set for this particular pattern as key, and the value will be an empty array. Next we just insert the word as a value to this particular key. So adj list dot get pattern dot push the word. Okay, so now once we got our adjacency list, we need to run a BFS on this graph. So for that we'll need few things. We'll need a visited set. So visited equal to new set. We'll add a begin word to our visited set initially. So we'll add begin word. We'll need a queue as well. So queue equals to an array with a begin word in it, and a result variable containing the number of words in the sequence. Initially it will be 1. Now let's run the BFS. So while there is something present in our queue, so while queue dot length, we first create the size of our queue. So we get the size of a queue. So const length equals to queue dot length. Now we run a for loop until this length becomes 0. So it will start from I for let I equals to 0, I is less than length, and I plus plus, and I plus plus. Now we do the same thing. First we pick the word from our queue. So word will be equal to queue dot shift. It will remove the first element from our queue, and it deletes it as well from our queue. Now we check if it is equal to the end word. So if word is equal to the end word, that means we just return the result, the count which we were calculating up to now. Else, if it doesn't, then we need to get all the possible patterns, all the possible words from our adjacency list, and push them to our queue. So for let j equals 0, j is less than m, j plus plus. Same thing what we did while creating the adjacency list. We'll create a pattern first. So word dot substring from 0 to j, 0 to j, then add an asterisk to it, then word dot substring the remaining part of the word, which will be j plus 1. Now we get all the possible values from our adjacency list. So const neighbors equals to adjacency list dot get that particular pattern. Now we loop through all of these all of these words one by one that were matching this pattern. So for neighbor, any neighbor of neighbors, if it is already not visited, so if not of visited dot has neighbor, if it is already not visited, something is wrong. Neighbor, oh, let me use let here. Yep. So if it is already not visited, then first we add it to the visited set. So visited dot add neighbor, and we push it to the queue as well. So queue dot push neighbor, and outside this for loop, we'll update the value of our result by 1. And if at any point this word matches with the end word, we return the count. If no such word is found, then at the end we'll just return 0, stating that no such sequence exists. So this is the code. If we run this, while q equals to begin word, oh, I misspell it, so begin. Okay, let's run it again. It's working. Let's submit it. Cool. So that was it for this video. Thank you for watching.